Looking at the next question, we'll be dealing with the complex number z that's given to us as that expression, and we are asked to simplify it, right? Leaving it in the general form a plus ib, right? So let's do that. So that's sub question A. Well, we know that a general rule when you have the quotient of two complex numbers is to always try to get rid of the complex numbers in the denominator. So you need, when you have an operation that you're doing involving complex numbers dividing each other, try to leave the final answer with no complex numbers in the denominator, right? In other words, try to multiply by the conjugate so you can eliminate the complex number in the denominator. Okay, so that's something that you should keep at the back of your mind when you're dealing with these problems. So the original problem that's given to us is 1 plus 2i multiplied by 2 minus 3i, all divided by 2 minus I multiplied by 3 plus 2i. Now, the first thing that we'll do here is expand. Let's expand both in the numerator and denominator. What do we get? We have 2 minus 3i plus 4i plus 6, right? Because you have 2i times 3i, which will give you 6i squared, and you know that that's negative 6i squared, and you know that I squared is negative 1, so you have negative 6 times negative 1, which is 6. In the denominator we have 6 plus 4i minus 3i minus 2i squared, which is just plus 2. Numerator will have 8 minus I. Denominator you'll have 8 minus I as well, which if you simplify you'll find that just gives you 1. But remember, we are asked to leave it in this form, so that is just 1 plus 0i. So it's a complex number with the real part being 1 and the imaginary part being 0. Okay, so that's how you would describe it. Now, moving on to sub question B, we are asked to find the 3 roots, again 3 roots of the equation z cubed is equal to negative 1 plus I. First things first, what is r? What is theta? Well, we know that r is just equal to the square root of x squared plus y squared, and that is just equal to the square root of negative 1 squared plus 1 squared, which is just root 2, and theta is tan inverse of 1 over negative 1, which is equal to tan inverse of negative 1, which is equal to what? Well, what's the angle for which the sign is positive? Because as you can see, the numerator is positive here. The sign is positive and the cosine is negative, and it has a tan of negative 1. So that angle has to be in the second quadrant first, right? Based on the signs of the sine and the cosine, has to be in the second quadrant, and it has to have a tan of negative 1, meaning that angle has to be some sort of multiple of pi over 4, because we know in the first quadrant tan of pi over 4 is equal to 1. So it's a multiple of pi over 4 in the second quadrant, and that is just equivalent to 3 pi over 4 if you actually do the calculation. Right, so then now that we have that, we have r, we have theta, we can find the roots. what's the first root? Well, the first root is, if you go back to De Moivre's theorem that we laid out in the first problem, the first root will just be r to the 1 over 3, which is root 2 to the 1 over 3. And the first angle would just be 3 pi over 4 plus 0, right? Because k is equal to 0, k is equal to 1, divided by 3, which is the equivalent of root 2 to the 1 over 3, with the angle being pi over 4. And that is just equal to root 2 to the 1 over 3 is just 2 to the 1 over 6. And that is just multiplied into cos of pi over 4 plus I sine of pi over 4, which is just equal to 2 to the 1 over 6, multiplied into root 2 over 2 plus I root 2 over 2. And that's our first root. What about the second one? Our second one is same r value, root 2 to the 1 over 3, which is 2 to the 1 over 6, multiplied, first let's find the angle. The angle is, once again, 3 pi over 4, plus now 2 pi, right, because k is equal to 2, all divided by 3. And that gives us 2 to the 1 over 6, with the angle being 11 pi over 12. And that is just equal to 2 to the 1 over 6 multiplied into cos of 11 pi over 12 plus I sine of 11 pi over 12, which is, if you evaluate, is just 2 to the 1 over 6 multiplied into negative root 6 plus root 2 divided by 4 plus I multiplied into root 6 minus root 2 divided by 4. So that's our second root. Right, so then our third root is, once again, same r value, 2 to the 1 over 6, and the angle is just 3 pi over 4 plus 4 pi now, because k is equal to 3, divided by 3. This is equal to 2 to the 1 over 6, with the angle being 19 pi over 12, which is just equivalent to 2 to the 1 over 6 multiplied into cos of 19 pi over 12 plus I sine of 19 pi over 12. And that's the third root. So we found all three roots as the question requested, and those are the final answers. So as you can see, the cubed meant that we had three roots, right? The question didn't even have to say find the three roots. You could just say find the roots, and immediately you would know that you have to find all three roots because you have a cube there. Right, so moving on, the next question is asking us to consider the complex number that's given to us as negative half plus root 3 over 2i, and we are asked to write it in polar form, right? First of all, we have to find again what's r, what's theta. We need that for the polar form. So r is just the square root of x squared plus y squared, right? And that is just equal to the square root of negative 1 over 2 squared, which is 1 over 4, plus root 3 over 2 squared, which is 3 over 4, which is just root of 1, which is 1. Theta is tan inverse of y over x, which is tan inverse of y, which is root 3 over 2 divided by negative 1 over 2, and that's just tan inverse of negative root 3. And what angle has tan of negative root 3 with a cosine negative and a sine positive? So that angle has to be in the second quadrant again, right? If you look at the trigonometric circle, the first quadrant, and this is the sine axis, this is the cosine axis. The first quadrant, all values are positive. This is the center. And the second quadrant, sine is positive, but cosine is negative. Third quadrant, sine is negative and cosine is negative. Fourth quadrant, sine is negative, cosine is positive. So our angle has to be in the second quadrant again, and it has to be, and if you figure it out, you'll see that the angle is just 150 degrees or 5 pi over 6 radians. So we have our r, we have our theta. We can write the general polar form. So z in polar form is therefore equal to r times cos of theta plus I sine theta, right? So that's the general form. Based on the r that we found, that's equal to 1 multiplied into cos of 5 pi over 6 plus I sine of 5 pi over 6. And that's the polar form. Now the second question is the exponential form. We know that the general exponential form is r times e to the I theta. That's the exponential form. Well, based on the r that we have, that's just 1 times e to the I of 5 pi over 6, right? And this is just equal to e to the 5 pi over 6i. That's our final answer. Okay, so that's our exponential form. The last question is asking for z to the 9. Now we'll be using the Moivre's theorem here. Again. But this time we'll be using the first theorem that is in your notes. And that's for when you have to find you have to raise a complex number to some exponents, right? And the rule just tells you that if you have it written in polar form already, z to the n will be just r to the n multiplied into cos of n theta plus I sine of n theta. That's just the rule. And meaning that our z to the 9 will just be r to the 9 multiplied into cos of 9 theta plus I sine of 9 theta, which is equal to, our r is 1, so 1 to the 9 multiplied into cos of 9 times 5 pi over 6 plus I sine of 9 times 5 pi over 6. And that is just equal to 1 multiplied into cos of 15 pi over 2 plus I sine of 15 pi over 2. Now you have to write it in this form and not leave out the 1, because the 1 tells you that that's the R value, radius. So just pay attention to that, but otherwise that's the final answer there, right? So let's see how far we can push it again. Let's have a look at the next one. Next one is an interesting one, because you're given the value of a complex number z, which is equal to negative 3 plus 4i, and you're given the value of the products of two complex numbers, z and w, which is equal to negative 14 plus 2i, and you are asked to find w, basically, and the modulus of the complex number w, which in other words find the R value, what's that, and also the argument of the complex number w, which in other words just means find theta. Okay, so first step, we have z times w. How do we find w? Well, w will therefore just be z times w divided by z, right? Meaning that's just be equal to negative 14 plus 2i, if I'm not mistaken, divided by negative 3 plus 4i. Again, if you go back to the the golden rule when you're dealing with quotients of two complex numbers, do not leave the imaginary numbers in the denominator, so get rid of them. So how do you do that? You multiply both the numerator and the denominator by the conjugate of the denominator, which is just negative 3 minus 4i, both in the numerator and the denominator. And that just gives you, if you expand, 42 plus 56i minus 6i plus 8 divided by 9 plus 12i minus 12i plus 16, which is equal to, when you simplify, 50 plus 50i divided by 25, which is just 2 plus 2i. So that is the value of our complex number w. And the modulus, represented by the absolute value of w, which is r, is just equal to the square root of 2 squared plus 2 squared, which is root of 8, which is equal to 2 root 2. And the argument of the complex number w, which is just theta, is tan inverse of 2 over 2, which is tan inverse of 1, which is pi over 4. How do you know it's pi over 4? Because we have both the sine and the cosine positive. So both the cosine and the sine are positive values, which indicates to us that the angle is in the first quadrant, and the angle that has a tan of 1 in the first quadrant is pi over 4. So that's that. Alright, hopefully that makes sense. Let's have a look at another one. Well, I'll set up these for you so you can continue from here. Well, this one can be easily implemented because you guys have seen me solve question, was it? Yes. So 4 sub question C. So you can easily implement that rule there. So now the tricky one might be question 7. A little bit tricky. but it makes sense if you sort of think of it as a quadratic equation. So what would you do to solve a quadratic equation, equivalent of a quadratic equation in this form? So you'd factorize, right? So you have, they're asking you for the roots, right? So you have basically, again, because the highest order in this equation is 4, you know that the roots, you'll have 4 roots, right? So since you know that, let's see if we can factorize. We have z to the 4 plus, and we can rewrite it as plus 4z squared plus z squared plus 4 is equal to 0. You can see that the z squared is common in the first two terms. Factorizing that, we have z squared multiplied it to z squared plus 4 plus z squared plus 4 is equal to 0. Z squared plus 4 is a common factor. We take it out. We have z squared plus 4 times z squared plus 1 is equal to 0. And whenever we have a factor being equal to 0, that means either one of them or both are equal to 0. So either z squared plus 4 is equal to 0 and or z squared plus 1 is equal to 0. So this will give you 2 roots, and that will give you 2 roots, which gives you the 4 roots that you are expected to find. So solve these two, get all the roots, and you should be able to find which one it applies to in the options that are given there. Right, so I think that is it. The next one is also similar. I mean, you can easily apply it. You're given 2 complex numbers, z and w. You can just, and you're asked to find the conjugate of the product of those two. You just multiply both. First, multiply z and w, and then finding the conjugate of that is easy work. So first you multiply, find the conjugates in the general form a plus b I, and then you have to find the r value and the theta value for that conjugate, so you can express it in the polar form, right? Which we've done before. So that should be easy to implement. Okay, so I believe that is it. Well, the next few ones are similar to stuff that we've done already. So like, for example, this one, question 9, and so you can easily solve this. Again, you have z squared, meaning 2 roots, easy to implement. Right, so thank you for watching the video. Hopefully it's helpful, and good luck, and I hope that everything works out well. Thank you for watching. I'll see you guys in the next one. Thank you. Bye.